I'm Smriti Chaudhury, and I'll be showing how to solve the Math Kangaroo 2025 grades 9 to 10 questions. Let's get started. Number 1. The trifold leaflet shown below includes transparent windows, allowing what is below to be clearly seen when the flaps are folded over. We fold over the left flap and then the right flap. What is the sum of the numbers that can be seen through the windows? So first, let's find the numbers. So if we were to fold over the left flap, it would show these numbers over here. And then when we fold the right flap, we see these numbers. So the two numbers seen are 9 and 5. And since we're being asked for the sum, we'd add them, which is 14. So our answer is 14, which is D. Number 2. The base of a triangle increases by 50%, and its height decreases by 1/3. What is the ratio of the area of the new triangle to that of the original triangle? So the area of a triangle is half base times height, right? And then the area of our new triangle is going to be half times the modified base, which is 50% increase, so 3/2, B, times our modified height, which is decreased by 1/3, so now it's 2/3, H. And now 3/2 can cancel with the 2/3 because multiplied, that's just 1. So now we've got half BH. So the area of the original triangle is the same as the area of the new triangle. So their ratio of their areas would be 1:1, which means our answer is B. In which of the following hexagons is exactly 1/3 of the area black and exactly half of the area white? So the hexagons are cut into 6 pieces. So 1/3 of 6 is 2. So we expect 2 black pieces. And half of 6 is 3. So we expect 3 white pieces. So let's look at our options. A has only 1 black piece, so that's ruled out. B has 2 black pieces, but only 2 white pieces, so no to B. C has 3 black pieces, so that's gone. D has 2 black, but only 1 white, so no. That leaves us with E, which has 2 black and 3 white. So our answer is E. Number 4. Kangaroo Day takes place every year on the 3rd Thursday of March. Which date is the earliest possible date for Kangaroo Day? So if we want this to be the earliest, we'll say the first day of March is a Thursday. So we're going to say March 1st is our first one, okay? And then we're going to go to next week. We're going to add 7 days because 7 days in a week. So our second Thursday is going to be March 8th. And we're looking for our third Thursday, which is Kangaroo Day. So we're going to add another 7 days, making Kangaroo Day March 15th. So our answer is B. Number 5. A recipe requires 1 cup of rice and 1½ cups of water. Reuben wants to use 1½ cups of rice. How many cups of water does he need? Okay, so we know the recipe for rice starts with 1, and then it becomes 1½ which is also 3/2. So let's write it like that. Now for water, the recipe has 1½ which again, let's write that as 3/2. And we're trying to figure out what to get. So for rice, in order to get 1 to 3/2, we have to multiply by 3/2. So let's do the same for water. Now 3/2 times 3/2 is 9/4. As a mixed fraction, that's 2 1/4. So he would need 2 1/4 cups of water, and our answer is D. Number 6. Lisa has 4 wooden digits. She can use them to form the number 2025. How many different numbers greater than 2025 can she form with these digits? And as shown, our digits are 2, 0, 2, and 5. Now, the easiest way to solve this question would be to just list them out because our greatest possible answer is 11. So let's do that. And we'll do this by listing them least to greatest by switching the numbers from the back and slowly working our way to the front. So we've got 2, 0, 5, 2, 2, 2, 0, 5, 2, 2, 5, 0, 2, 5, oh, that's a 2, 5, 0, 2, 2, 5, 2, 0, 5, 0, 2, 2, 5, 2, 0, 2, and 5, 2, 2, 0. And if we add them all up, we have got 8 numbers. So our answer is C. Number 7. Alex folds a square in half along a diagonal to make a triangle. Then he folds the paper again so that one of the short edges of this triangle lies on top of the long edge of this triangle, making the smaller triangle AXC as shown. What is the measure of AXC? So we started out with this square over here, which we then folded in half, getting this triangle. And then we folded it again in half this way, getting this triangle. And we're solving for the value of this angle, AXC. So we can get that by solving for the value of this angle, and then doing 180 minus those angles, because all angles in a triangle add up to 180. So here we see that angle CAX is the same as angle CAB in this triangle. So let's look for CAB here. That's this angle over here. We can solve for that because this is a square, and so squares have right angles. And since this is a diagonal, diagonals will cut the angles in half. So 90 divided by 2 is 45 degrees, which means that this angle over here is 45 degrees. Now, for finding ACX, which is this angle over here, we'll find that this angle is also 45, and ACX is this angle here, which is 45 divided by 2 again. So 45 divided by 2 is 22.5 degrees. So this angle is 22.5 degrees. Now for AXC, we will find that, okay, measure of angle AXC is 180 minus 45 minus 22.5. So 180 minus 45 is 135, and then minus 22.5 is 112.5 degrees. So our answer is B. Number 8. The 4-digit number 80 blank blank is missing its last 2 digits. The number is divisible by 8 and 9. What is the product of these 2 missing digits? So we have this number 80 blank blank, and we know that it's divisible by 8 and 9. So let's look over those rules. In order for it to be divisible by 8, the last 3 digits need to be divisible by 8. And since our third digit, which is the hundreds place, is 0, that means that these 2 digits need to be divisible by 8. Now, in order for this to be divisible by 9, the sum of the digits must be divisible by 9. So 8 plus 0, that's 8. So the missing digits must add up to 1 or 10, and not 18 because, oh, sorry, not 19, because the max they could add up to is 18, with this being 9 and 9. So the only things that are possible are 1 and 10. So let's try out some combos. We have 0, 1, and 1, 0 for digits that add up to 1, but neither of these are divisible by 8, so this is not possible. Now, in order for it to add up to 10, we can have 19, but oh, that's not divisible by 8. 28, which doesn't work. 37, which doesn't work. 46, nope. 64, which, okay, that is divisible by 8. Let's continue on, look for any other numbers. So 73, no. 82, no. 91, nope. Which means that 64 was the only number that worked. So our missing digits must be 6 and 4. But we're looking for the product of the digits. So our answer is 24, which means our answer is D. Number 9. Luca has some dogs, some rabbits, and some cats. 8 of his pets are not dogs. 5 of his pets are not rabbits. 7 of his pets are not cats. How many pets does Luca have? So one thing, when we're saying 8 of his pets are not dogs, that means the rabbits and the cats added up is 8 pets. And so let's move on with that. So let's call our dogs D, rabbits R, cats C. And let's write this down in equations. So 8 are not dogs, which means rabbits plus cats is 8. 5 are not rabbits, so dogs plus cats is 5. 7 are not cats, which means that dogs plus rabbits are 7. And we're trying to solve how many total pets, so that would be dogs plus rabbits plus cats. So one thing we can do is add up all these equations, which we would end up with 2D plus 2R plus 2C equals 20. And now if we were to divide this whole thing by 2, we would have D plus R plus C equals 10, which is the same thing over here. So Luca has a total of 10 pets, which is A. Number 10. A circle with center O and a radius of 10 centimeters is given. A square OPQR is drawn inside the circle, where Q is a point on the circle. What is the area of the shaded triangle PQR? So here's our circle, and this is the triangle that we're trying to solve the area for. And we were given that the radius is 10 centimeters. And one thing we can do is imagine this as the radius, which that is true. That is also the diagonal of the square. And both diagonals are equal, which means that if this is 10 centimeters, the other diagonal is also 10 centimeters. And since we know the hypotenuse of this triangle, we can now solve for the sides. And once we solve for the sides, we can solve for the area. So we know from Pythagorean theorem that a squared plus b squared equals c squared. And since this is a square, both sides are equal. So it's really more of 2a squared equals, and then c is 10, so 10 squared. We take the square root of both sides. We've got rad 2a equals 10. So a equals 10 over rad 2, which is 10 rad 2 over 2, which is 5 rad 2. So a side is 5 rad 2. But we're solving for the area of this triangle. So let's see. That would be half times a side, so 5 rad 2, times 5 rad 2, which is half times 5 times 5 is 25, and then rad 2 times rad 2 is 2. And now our 2 and our half will cancel out, which means the area of the triangle is 25 centimeters squared. So our answer is B. Number 11. An athlete has a collection of 2 gold and 5 silver medals. They're numbered from 1 to 7 in some order. The figure shows black and white photos of the medals. It is known that in each photo, exactly one of the medals is gold. What is the sum of the numbers on the 2 gold medals? So we know that in each of these photos, there is only 1 gold medal in each one. So let's go with this box. We know that there must be a gold medal in each one. So let's try them by case. So let's try if 1 were a gold medal. This box has a 1 and this box has a 1. So that would mean there has to be a common number between these 4 in order for that to be a gold. But there isn't any common number between these four, and that means 1 is not a gold medal. Now let's try 2. If 2 were a gold medal, let's see, it's common with this box, which means there needs to be a number that's in common in these 4 boxes, which there isn't. So 2 is not a gold medal either. Now for 3, there's a 3 in this box and in this box as well. So these 3 boxes would need a common number, which they do have, 6. So 3 is a gold medal, along with 6. So we're asked for the sum of the numbers, so 3 plus 6 is 9. So our answer is C. Number 12. Anna looks at a photo on her smartphone. The format is 16:9 and fills the whole display. When she turns the smartphone, the picture gets smaller. What fraction of the display area is taken up by the smaller picture? So first, we know the dimensions of her phone are in ratio of 16:9. And since she only turned her phone sideways and it didn't change shape, it's still 16:9. However, the photo did change shape. So now, instead of the shorter side being 9, the longer side is 9. Now let's solve for this side. Let's call that x. And once we do, we can find the fraction of the area that this display takes of the total phone. So let's write that as a proportion. We've got x over 9 is equal to 9 over 16. And let's solve for x by multiplying 9. So we get 81 over 16. Now we want to solve for the fraction of the display area this takes of that, which would be, so that's 9x, right? That's the dimensions of this rectangle, over 9 times 16. And we can cancel the 9's out, so we're looking for x over 16. And since we know that x is 81 over 16, we're looking for 81 over 16, which is 81 over 16 times 16, which is 256. So our answer is 81 over 256, which is E. Number 13. Kate and Tom are celebrating their birthdays today. Tom notices that 1/19th of Kate's age is equal to 1/17th of his age. The sum of their ages is greater than 40 and less than 100. How old is Kate? So first, let's call Kate's age K and Tom's age T. So we know that 1/19th K is equal to 1/17th T. And since we don't like fractions, well, let's convert that to, there we go. Let's convert that to whole numbers. And so we've got 17k equals 19t, because we multiplied both sides of this equation by 19 times 17. And now one thing that we need to notice is that it says that they're celebrating their birthdays today, which means that their ages are integers. So that means k is divisible by 19 and t is divisible by 17. So let's represent that by saying k equals 19 times some x and t equals 17 times some y. Now let's plug this in over here where we said 17k equals 19t. So that means 17 times 19 times x equals 19 times 17 times t. Oh, sorry, y. Here, let me fix that. So if we cancel these out, that means that x equals y. Now over here we were told for the sum of their ages is greater than 40 but less than 100. So that means k plus t fits that criteria. Now, k plus t, we can plug in. Here we've written 19 times x and 17 times y, except since we know that x equals y, let's plug in x for y. So we've got 19 x plus 17x, which is 36x. So we're trying to find an integer value of x that would fit this criteria. So here, let's try numbers 1, 2, and 3. Now, if x were 1, then it would be 36, which is less than 40, so that does not work. If x were 2, then we'd have 72, which does work. Now, if x were 3, then this would be 108, which is greater than 100, so that does not work, which means x equals 2. Now, we're solving for Kate's age, which means let's go over here and plug in 2. So 19 times 2 is 38, which means Kate is 38 years old, and our answer is C. Number 14. Paul shoots a total of 27 times at 2 targets. He hits 50% of the shots he aims at the top left target and 80% of the shots he aims at the bottom right target. He misses a total of 9 shots. How many times did he aim for and hit the top left target? So let's call the number of times he aims for the top left target L, and the number of times he aims for the bottom right R. So the total number of shots, which is L plus R, is equal to 27. And now 50% of the shots he aims at the top left, so half L, and 80% for the right, so 4/5 R, equals the number of shots he made. And since he only missed 9 and he made 27 shots, that means that 27 minus 9, 18, he made 18 shots. So now that we've got two equations, let's solve for our two variables. So here, let's say R equals 27 minus L. And now let's plug that in. So we've got half L plus 4/5 of times 27 minus L equals 18, which means half L plus 4/5 times 27 is 108 over 5 minus 4/5 L equals 18. Now, half L minus 4/5 L we'll do over in this corner. So half is also the same as 5/10 minus, and then we've got 4/5, which is also the same as 8/10. So 5 minus 8, we've got -3/10. So we have -3/10 L plus, and then 108 over 5 is 21 3/5 equals 18. So -3 over 10 L equals -3 3/5. So let's take the negatives away. Now we have 3/10 L equals, and now let's make this an improper fractions, 18 over 5. And that means L equals 18 over 5 times 10 over 3, because we multiply both sides by 10 over 3. And here we can cancel this out, leaving 6, and this leaving 2. So that means that L equals 12. So he made, or at least he aimed, 12 shots at the left target, but he only made 50% of them. So half into 12 is 6. So he made 12, he aimed 12, but he made 6 shots for the left target, making our answer 6. Number 15. Sarah has a bag of 18 balls, numbered from 1 to 18. What is the smallest number of balls Sarah should remove in order to guarantee that she has removed at least 3 balls with prime numbers on them? So first, let's list out all the prime numbers between 1 and 18. So we've got 2, 3, 5, 7, 11, 13, and 17, which is 7 numbers. So we've got 7 primes. And since we've got 18 balls in total, that means we have 18 minus 7, which is 11 non-primes, so numbers that are not prime. And so let's imagine the worst case scenario where she removes all 11 non-primes before she picks a single prime number. So we've got 11 non-primes plus and then her 3 primes. So she removes her 3 prime numbers after she removes every other number that's not primed. So that would be 14 falls, making our answer D. Number 16. David wants to place the numbers 1 to 8 in the 8 cells of the diagram, with one number in each cell. He wants the cells that contain 2 consecutive numbers not to share a side or a vertex. Which numbers can David put in the cell marked X? So first let's just list our numbers of 1 through 8 out. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And in the cells, they cannot share a side or vertex with a consecutive number. So 1 cannot share a side or vertex with 2. 2 cannot share a side or vertex with 1 or 3, and so on. So any number they are next to in the list we've listed out, they cannot share a side or vertex with. Now, let's look at these center cells over here. These cells share a side or vertex with 6 other cells, which leave the only possible options for them 1 and 8, because 1 cannot share a side or vertex with 2, which leaves 6 other numbers. And likewise, 8 cannot share a side or vertex with 7, leaving 6 other numbers. So, however, we do not know which order these 2 cells would be 8 or 1, so let's try both cases. So if this is an 8 and this is a 1, X would be the only number that 8 cannot share a side or vertex with, which is 7. So X would be 7 in that case. However, if this were 1 and this were 8, then X would be the only number 1 cannot share a side or vertex with, which is 2. So the possibilities for X are 7 and 2, or 2 and 7, which makes our answer B. Number 17. The number n is the largest 6-digit integer with the product of all its digits equal to 180. What is the sum of the digits of n? So we know that n is 6 digits, and we know that the product of its digits is 180. So let's look at 180. If we were to break it down, the highest single digit that we could get from it is a 9. So we'll put that in our highest place value. So now we're left with the 20. The highest single digit we can get from a 20 is 5. So we'll put that in our next highest place value and continue on. The highest place value, well, the highest digit that you can get from 4 is 4. So that means the rest of our places will be 1s. So our digits are 9, 5, 4, 1, 1, 1. So this is n. And we want to know the sum of the digits. So here we've got 9 plus 5 plus 4, which is another 9, plus 3 1s, so that's 3. So 9 plus 9, 18, plus 3, 21. So A is 21. Number 18. The 2 shaded rectangles are congruent. Each of the shaded rectangles have an area of 4. What is the area of the large rectangle ABCD? So we know that this rectangle and this rectangle have an area of 4 and are congruent, which means they share the same dimensions. So this width is the same as this width, and this length, same as this length. And we're trying to solve, knowing that, for the area of this large rectangle, ABCD. So our strategy would be to solve for this rectangle in terms of these smaller rectangles, and then plug in the value of 4 for them and find the value of the area of this large rectangle. So let's do that. We know that this angle is congruent to this angle by vertical angle theorem, which is basically saying this angle plus that angle is 180, and this angle is plus that angle is 180, since straight lines. And since this angle didn't change, that means both these angles have to be the same in order for them to both add up to 180 with this angle. So basically that means these two angles are the same. Now, since this is a rectangle, we know that this is a right angle. And since this is a rectangle and this is a straight line, this is also a right angle. Now, earlier we said that these rectangles are congruent, meaning they have the same dimensions. So the width of this rectangle is the same as the width of this rectangle. And at this point, now that we know these two angles are the same, we can also say these two angles are the same. Now, when we know that the angles of these two triangles match, we can say that they're similar. And since we know one of their sides are also matching, that means that both these triangles are congruent. So that means if I were to cut this triangle out and put that over here, then I'd still have the same area. So let's do that. So I'm cutting this triangle out and putting it over here. So now this large shape has an area of 4 still. Now over here, this rectangle, if you notice, this line is its diagonal, meaning that this rectangle is being cut in half. So its area was also cut in half, meaning the area of this portion is 2. So that means the area of this triangle ADC is 6. And we're looking for the area of our rectangle ABCD, right? And that can be also written as 2 times the area of triangle ADC. Oh, triangle ADC. And since we found that the area of triangle ADC is 6, that's 2 times 6, which is 12. So the area of this rectangle, the area of this rectangle is 12, which is D. Number 19. The product of 3 prime numbers is 11 times their sum. What is the largest possible value of their sum? So let's call our 3 prime numbers A, B, and C. So we're saying A times B times C is equal to 11 times A plus B plus C. So since A, B, and C are prime numbers, and over here we're saying that A times B times C is divisible by 11, that means that one of them has to be 11. So let's call A 11. That would mean 11 BC equals 11 times A plus B plus C. And we could simplify this by dividing both sides by 11. So now we have BC, so B times C, equals A plus B. Oh, A is 11. I forgot to rewrite that. So that's 11 plus B plus C. Now let's try some values for B and C. So what if they're both 4? Then 4 times 4, that's 16. And 4 plus 4, 8, plus 11, that's 19. Okay, so now the left side is less than the right side. What if we were to try 5? Then 5 times 5, we've got 25. And, oh, that's a 5. And 5 plus 5, 10, plus 11, 21. So now the left side is greater than the right side. So that means that one of these numbers has to be less than 5 in order for this to balance out. So there are only 2 prime numbers that are less than 5, and those are 2 and 3. So let's try them out. So let's plug them in for B. Let's say 2C equals 11 plus 2 plus C. So 2C equals 13 plus C, which means that C equals 13. So our values for that case would be 11, 2, and 13. Now let's try 3. There we would have 3C equals 11 plus 3 plus c, which would mean 3c equals 14 plus c. So 2c equals 14, which means c equals 7. So in this case, we have 11, 3, and 7. And now looking at these two sets, it's obvious that this set has the largest possible sum. So the sum of this is 11 plus 2, 13, 13, 13, 26. So our answer is E. Number 20. 5 bricks are placed on the ground, as shown. Peter can only remove a brick if there are no bricks on top of it. He selects one of the available bricks at random and removes it until all the bricks are removed. What is the probability that the brick numbered 4 is the third brick to be removed? So for our first brick, there are 2 bricks to pick from, but both of them would help towards the third brick being picked. So 2 out of 2 probability of picking a brick that would help for that. Now let's say that we picked brick 1. So now brick 1 is gone. Now there are 2 bricks to pick from, 2 and 3. Out of them, we would like to pick brick 2, so that brick 4 can be our third brick. So there's a 1 out of 2 chance. Now, there are 3 bricks possible, since 2 is gone. And out of them, we would like to pick brick 4, so there is a 1 out of 3 chance. And multiplying this out, since this cancels out, because that's 1, we get 1/6. So there is a 1/6 chance that brick number 4 is the third brick, making our answer D. Number 21. The square ABCD contains 2 rectangles. One is gray and the other striped, with dimensions as shown in the diagram, not to scale. The area of the overlapping part of the 2 rectangles is 18 centimeters squared. What is the perimeter of ABCD? So the strategy to solving this would be to find the dimensions of this rectangle, because once we know the length of how much is overlapping, we can find the dimensions of square ABCD and then find its perimeter. So we know that this is 18 centimeters, and let's see, 18 can be, assuming this is going with integers, it can be 1 and 18, can be 2 and 9, or 3 and 6. Now, it can't be 18 because we've got 7 and 8, and this is smaller than both, so 18 is not possible. And neither is 9 with that logic. So that means the dimensions must be 3 and 6. Knowing that, we know that this is 7 centimeters, and this is overlapping 6 centimeters, which means this has to be 1 centimeter. No, this is 1 centimeter. Same way, we know that this is 3, and we know that this is, we know that this is 7, and that this is 3, which means this has to be 4. And since we know that this is 1 and 8, that means this is 9. And since this is 4 and 5, this is also 9. And technically, I didn't need to solve for both, since this is a square, so they were already going to be the same. It's good to check your work. So we want the perimeter of ABCD, which is going to be 9 plus 9 plus 9 plus 9, which is 4 times 9, which is 36. So our answer is 36, which is C. Number 22. A 4-digit integer ABCD is multiplied by its units digit D. The result is a different 4-digit integer, dxya, which has the units and thousands digits of the original integer interchanged. How many 4-digit integers ABCD have this property? So ABCD times D equals dxya. So A and D get switched. So here let's notice a few things. So D times D has a units digit of A. So let's write that down. And let's also notice that d times a equals d. And let's also consider that there may have been some carryover from d times b. So that means that d is greater than or equal to d times a, because it'd be greater if it got some carryover from d times b, but equal if it didn't. So the only way for this to work, considering that this is the product is a 4-digit integer, would be if a is 1, which means that d equals d times a. So let's write that. A equals 1. Now if a equals 1 and d squared has units place of a, let's look at what d could be. So d could be 1, 1 squared is 1, and it could also be 9, because 9 squared is 81, so it ends with a 1. However, d can't be 1 because when you swap the place of a, b, c, d, we end with dxya, where d and a switch places. And if it was 1 and 1, then they wouldn't be switching places. And since we know that a is 1, that means d is not 1. So d must be 9. So let's write down what we do know now. We have 1bc 9 times 9 over 9xy 1. So while we're looking at this, okay, so we have 9 times 9, 81. So we've got a carryover of 8, which means that 9 times c, okay, well, 9 times bc would, well, 0, 0 is an opportunity for them. Anything that starts with a 0 works. So 0, 1, 0, 1, 0, 2, so on. And 1, 0 would also work. But after that, it wouldn't, because if 11, then 9 times 1, that's 9 plus 8, 17. So there'd be carryover, which means there's another carryover for b, making our product a 5-digit integer. So here we can only have 0, 0, 0, 1, 0, 2, so on, up till 10, which is 11 numbers. So there are 11 different integers possible that fit this criteria. So our answer is E. Number 23. Daniels numbers certain squares on a sheet of grid paper. Each square has a side length of 0.5 centimeters. He starts with the first square and then numbers the squares 2, 3, 4, 5 in a counterclockwise direction as shown. He stops when he has numbered 2025 squares and looks at the figure made up of all the numbered squares. What is the perimeter of this figure? So he started at 1 and then started numbering in the spiral as shown. And one thing to notice is that for any perfect square, the figure is a square. Like 1 has a square, 4 would have a square if you were to continue numbering. This 9 would be a square, and we can only assume the pattern would continue. So another thing to notice is that the side length is the square root of that perfect square. So the square root of 9 is 3, so the side length is 3. The square root of 4 is 2, and the side length is 2. The square root of 1 is 1, and the side length is 1. Now it just so happens 2025 is a perfect square, and its square root is 45. So the figure at that time would be a square with a side length of 45. So you'd think its perimeter is 45 times 4 to account for all sides. However, each square has a side length of 0.5 centimeters. So instead of this being 1, this only counts for 0.5. So we would have to multiply this by 0.5. Now 4 times 0.5 is 2, so now we have 45 times 2, which is 90. So the perimeter of this figure is 90 centimeters, making our answer D. Number 24. ABCDEF is a 6-digit number made up of the digits 1, 2, 3, 4, 5, and 6, with no repeated digits. Its first 2 digits, AB, is a multiple of 2. Its first 3 digits, ABC, is a multiple of 3. Its first 4 digits, ABCD, is a multiple of 4. Its first 5 digits, ABCDE, is a multiple of 5. And the full integer, ABCDEF, is a multiple of 6. What is the 6-digit F? So we have 6 numbers over here. A, B, C, D, E, and F. And one thing to notice is that when they say AB is a multiple, B must be even of 2. ABCD is a multiple of 4, D must be even. And when ABCDEF is a multiple of 6, F must be even. So we know that B, D, and F are the even numbers, which means that A, C, and E are the odd numbers. Now, another thing to notice is that A, B, C, D, E is a multiple of 5, which means that E is either 0 or 5 by the divisibility rule. And since we don't have 0 as an option, E must be 5. Another thing to notice is that since E is 5, A and C are 1 and 3, though we don't know the order. We do know that A plus B plus C has to be divisible by 3, since ABC is a multiple of 3. And since we know that A and C are 1 and 3, though we don't know which ones, 1 plus 3 is 4. So we know that B plus 4 is divisible by 3. Now, B can either be 2, 4, or 6. Now, if it were 6, 6 plus 4, 10. 10 is not divisible by 3. If it were 4, 4 plus 4 is 8, which is also not divisible by 3. But if it were 2, 2 plus 4 is 6, which is divisible by 3. So B must be 2. Now, looking at here, ABCD is a multiple of 4. So that means that the divisibility rule states that the last 2 digits, which would be CD, have to be divisible by 4. Now we know that C is an odd number, so let's say it was 1, then D can either be 4 or 6. Now 14 is not divisible by 4, but 16 is. Same way, if C was 3, 34 is not divisible by 4, but 36 is. So D must be 6. Which means that F must be 4. So our answer is B, which is 4. Number 25. In the diagram below, the diameter of the inner circle forms part of the diameter of the outer circle. The outer circle has a chord of length 16 that is parallel to its diameter and is also a tangent to the inner circle. What is the area of the shaded region? So let's redraw this first. Let's move our smaller circle to the center, relatively. We've got our chord, that is 16. And let's call this smaller radius R, and our larger radius capital R. Now, the area of the shaded region would be the area of the larger circle minus the area of the smaller circle, which is pi capital R squared minus pi lowercase r squared. Now, another thing that we can do is recognize a shape here, which is a triangle. Here, the hypotenuse of the triangle is R, capital R, and a leg is lowercase r, with the other leg being 8, which is half of our chord. So let me redraw this triangle. We have R, R, and 8. Now, if we were to write this in Pythagorean theorem, we know that that means R squared equals 8 squared plus R squared, which we can rewrite this as r squared minus r squared equals 8 squared, which is 64. Over here, we can pull out the pi and rewrite this as r squared minus r squared. Now, since we rewrote this over here and now see that r squared minus r squared equals 64, we can plug that in over here. So now that means our shaded region is 64 pi. So our answer is C. Number 26. A sequence of numbers A1, A2, A3, A4, and so on till A10 is such that from the third term on, each term is equal to the mean of all the previous terms. That is, A3 is the mean of A1, A2, A4 is the mean of A1, A2, and so on. In this sequence, A1 equals 8 and A10 equals 26. What is the value of A2? Now, one thing to realize is that in such a sequence, if we have A1 plus A2 over 2, and we know that that's A3, realize that A4 is equal to A3 plus A1 plus A2 over 3, right? Okay. And A3 equals A2 plus A1 over 2. So we can multiply this upper part by 2. So, well, we multiply both parts by 2. So now we have A4 equals A1 plus A2 plus 2A1 plus 2A2 over 6. So A4 equals 3A1 plus 3A2 over 6, which is A1 plus A2 over 2. And realize that that means A4 and A3 are equal. And so the point of this is that if you're taking the average of two terms, now that's your average. Now you're adding up the average plus the average and taking the average of that, you're going to get the average again. And so every value after A2, so A3, A4, and so on, is going to be the same value, which means A10 is also the same value as A3. So here we know A3 is A1 plus A2. So we're saying 26 equals 8 plus A2 over 2, which means that 8 plus A2 equals 52, which means A2 equals 44, which is D. So our answer is D. Number 27. 6 circles are arranged in the shape of a triangle as shown. John writes the digits from 1 to 6 inside the circles so that the sums of the numbers in the circles on all 3 sides of the triangle are the same. He then calculates the sum of the numbers in the 3 circles at the vertices of the triangle. How many possible values could he obtain for the sum? So the one property about this triangle is that the sum of the numbers on these 3 circles is the same as this and this. So let's call this S for side. So 3S, the sum of all sides, would equal the sum of all digits, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is, let's see, 3, 6, 10, 15, 21. So 21 plus the sum of the vertices because they're being counted twice. And one thing to notice about that is that that means our sum of vertices must be divisible by 3, because when we divide both sides by 3, our sides would be integers, because the values in the circles that are being added up are integers. So we'd end up with 7 plus something, and it has to be divisible by 3. So our lowest value for the sum of vertices is 1 plus 2 plus 3, which is 6, and so happens to be divisible by 3. And our highest value is 4 plus 5 plus 6, which is 15, and also is divisible by 3. So these two are possible. In between, we also have 9 and 12 that are divisible by 3. So that's a total of 4 different values that John could get for the sum of the vertices. So our answer is 4, which is D. Number 28. At a party, there are 12 children, including 3 pairs of twins. How many ways are there to distribute 6 blue hats and 6 red hats to the children so that in each pair of twins, both children are wearing hats of the same color? So basically, the twins will always have the same hat color. So there's 2 cases to consider. Case 1, all the twins have one color and all the other kids have another color. And in that case, there are 2 ways. The twins have red and the other children have blue, or the twins have blue and the other children have red. So 2 ways. Case 2 is that for the twins, 2 twins have one color and one pair of twins has the other color. So we've got 2 in one color and 1 in other. So there's 2 ways to know which color. So the majority color could be red or the majority color could be blue. And there's 3 ways to know which of the 3 pairs ends up in the minority color. So there's 6 ways to pick hats for the twins. And now, considering the other children, we have, let's consider the majority color for the twins. We have 2 more hats of that color. So since that color's already been picked, we don't need to consider that. And since there's 6 kids, so there's 6 times 5. However, it doesn't matter the order that they get the hat, so divide that by 2. So we have 15. So then the different ways to pair up the twins and the normal other children, 6 times 15, which is 90. So the total number of ways to distribute the hats is 90 plus 2, which is 92. So our answer is C. Number 29. Triangle ABC has an area of 60. Point I is the midpoint of side BC, and points J and K divide side AC into 3 equal segments. Point L is the intersection of AI and BJ. Find the area of triangle ALJ. So we know that I is the midpoint, which means BI and BIC are congruent. And we also know, since these are divided into 3 equal segments, AJ is congruent to JK, is congruent to KC. And we would like to find the area AJL. Now, in order to do that, let's divide this a little more nicely. Let's draw a line right here to make a triangle like that. and another over here, which looks weird, but I'll explain why. So let's call the area of AJL X. Now, since we know that AJ is the same length as JK, and they have the same side over here and they meet at the same point, we now know that their areas are the same. So this is also the area of X. And since side KC is the same length and also meets at the same point, its area is also X. So now we know that these all have the same area. Another thing here, let's call BIL, triangle BIL's area, Y. Now since BI and IC have the same length, triangle LIC has the same area as LBI, since they meet at the same point. So this is also an area of Y. And we know that this has an area of 60. Now this is important because the line AI cuts the triangle in half, which means that 3x plus y equals 60 over 2, which is 30. Another thing is that here, BK, BJ cut the triangle into thirds. So now we know that 2y plus 2x equals 2/3 of 60, which is 40. And since we have two equations, two variables, we can now solve. So here, let's say y equals 30 minus 3x. And now let's plug that in here. So 2 times 30 minus 3x plus 2x equals 40. So 60 minus 6x plus 2x equals 40. So 60 minus 4x equals 40. So subtract 40 from both sides, we've got 20, and then add 4x to both sides equals 4x. So x equals 5. So we said that the area of AJL was x. So that means that the area of AJL is 5. So our answer is B. Number 30. Anastasia wants to write the numbers from 1 to 8 into the cells of a 2x4 grid. The number in each cell must be smaller than the number in the cell to its right and smaller than the number in the cell below it. In how many different ways can Anastasia fill the grid? So one thing to note is that 1 will be the smallest number and 8 will be the largest. So 1 would always be in the top left corner, and 8 will always be in the bottom right. Now, as for the others, the only other two special cases would be 2 and 7, which have 4 places they could be arranged. 2 can be in this box or this box, and 7 can be in this box or this box. So let me draw out the situations. So 1 and 8 will always be these two corners. Now over here we could have 2 and have 7 over here. We could have 2 and 7 over here, 2 and 7 over here, and 2 and 7 over here. So these are 4 different ways we could arrange those. Now let's look at the first one over here. We have 3, 4, 5, and 6 that can be arranged. Of those numbers, this could be we could have 3, 4, 5, 6, or we could have 4, 3, 5, 6, or could have 5, 3, 4, 6, but the number that wouldn't work is 6, 3, 4, 5, because 6 is greater than 5, so this would not work. So there are only three ways we can arrange the numbers in this situation. Now in this situation, we can pair 3 and 4, or 3 and 5, or 3 and 6, and the other two numbers would be the other pair. So there's 3 different pairs we can make, and 2 different places we can put them. So 3 times 2 is 6. So this one has 6 ways. Here we can have 3, 4, 5, 6, or we can have 3, 5, 4, 6, or I think that's it actually. 6 cannot go up here because there's 4 and 5 are less than 6, so that's not possible. So there are only 2 ways we can arrange these numbers. Here we can have 3, 4, 5, 6, or we could have 3, 4, 5, 6, or 3, 4, 5, 6. So that is 3 ways. So if we were to add up our ways, we've got 3, 3, that's 6, plus 6, 12, 2, 14. So there are 14 different ways Anastasia can fill out this grid. So our answer is E. Thank you for watching. Good luck with Math Kangaroo. Goodbye.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website. So bye!